All right, Cal Kids, I am home today. I'm going to record the last little bit of your notes and then give you guys time to work in class on this section. My little boy is playing in the background, so you can kind of hear toys going and music playing, whatever. So we got done yesterday with the example at the top of the second page, the cotangent, but now we're going to talk about the reciprocal function. So that's where we're at for the notes. And graphing cosecant and secant are the two that we have left to talk about. And cosecant, when you graph cosecant, you are going to graph sine first. So graph sine first. And all of the normal qualities of sine apply, like the period is 2 pi, so when you do your A, B, C, and D, you will do exactly the same, like A is the amplitude, B tells me the period, but it's 2 pi over B that tells me the period, and that's the same as the way it was in sine. So cosecant, to find the period of cosecant, you'll use the same formula as you did for sine. Whereas cotangent and tangent, to find the period, you would just do pi over b. Well, we're back to 2 pi over b now. Negative c over b will tell me the phase shift or the horizontal shift. And then d just tells me the vertical shift. So that is true for cosecant and for secant. And then we just graph those like normal. The only difference is when we have sine, so I don't know if you can kind of see, let me do a different color. If you can kind of see the sine function right here, this is what sine looks like. Okay, then what you will do is where your middle line is, which is usually on the x-axis, where your middle line is hitting your sine function, like at these dots right here, this is where vertical asymptotes will be. Okay, so wherever your middle line is at, usually the x-axis, unless we're moving them up or down, you're going to put dots there, and that's where your vertical asymptotes are going to be. And then the only difference is off of your sine function, the cosecant graph will be, this is what cosecant looks like. It's this part. They're like little parabolas coming off of the sine function. Okay, same thing with cosine and secant. So we can see like cosecant or cosine here, this guy. And our middle line is here. So our vertical asymptotes are going to connect at each one of these points. And so we have vertical asymptotes here and here and here. And then our secant function is just going to be the parabolas off of that. Something of that nature. And then, I don't know, they did like partial one here. Whatever. So anything like that, that's what secant's going to look like. You just have to place the vertical asymptotes in the correct spot, and then the hyperbolas or the parabolas are going to branch off of the highs. The maximums and minimums is where it's going to they're going to branch off of. Okay, so let's use that to graph. I think I just have one of them here. So when we're graphing 2 cosecant of x plus pi over 2, we're going to start by doing sine. Okay, so let's do a, b, c, and d. And really we only have an a and a c, but let's go ahead and write in b and c and d. D, we don't have one. A is 2, so the amplitude is 2. B, there's really kind of like a 1 in front of here. So B is 1, but that just means 2 pi divided by 1. That means my period is just 2 pi. So it stays normal. And then C, we do negative C, which is pi over 2, divided by B, which is just 1. So negative pi over 2. That's going to be my phase shift or my horizontal shift. Okay, so we've got all of that information. We're going to start by graphing sine first and not cosecant. Okay. And we're shifting them to the left, pi over 2, so give a little bit of room to the left that we can do that. Okay. All right, so we are here at negative pi over 2. And what I'm going to do is I'm going to do a positive pi over 2 over here on the same side. And then that would mean like this would be pi, this would be 3 pi over 2, and this would be 2 pi. Okay. So sine is starting at negative pi over 2, and if we're going 2 pi from that, if it helps you to think about it this way, you can do it this way. pi over 2 plus 2 pi, because our period is 2 pi, we're going to figure out where we're going to end. We could change that to 4 pi over 2, and that would be 3 pi over 2. So this is where he's going to end at. Okay, he's going to start at negative pi over 2 and end at 3 pi over 2. Okay, let me erase that quick. That's my starting and ending point. Okay, so, and we're doing sine, the sine function. All right, so he's going to start here, he's going to end here, and he's going to cross here in the middle. Okay, so he's going to go up, come down, and come back up again, because normally sine does one of these. That's what he's going to look like, okay? Except now he's going to go up to 2 instead, and he's going to go down to negative 2. So he's going to be at negative 2 over here, and this is kind of what he's going to look like. Something of that nature. Okay, something like that. That is what 2 sine of x plus pi over 2 looks like. Okay, you might be able to see that if I would continue this on, this little guy right here, this guy is the graph of cosine, right? So if I continue that guy on, the x plus pi over 2 gives me the horizontal translation that turns sine into cosine. Okay, so one thing you may want to write over here is that sine of x plus pi over 2 is exactly the same thing as what cosine of just x is, right? It's just shifting him over pi over 2 units to the left, okay? But that will be exactly what cosine is, so that's kind of a neat little thing about him. All right, but now we're graphing cosecant. Graphing cosecant. So my middle line is here in the middle. Usually it's the x-axis unless we move him up or down. So he's hitting right here, right here, right here, and that's where my vertical asymptotes will go. Okay? And then all I need to do is graph the parabolas. And so he's going to touch here, and he's going to do one of these. And he's going to touch here, and he's going to do one of these. And that's what your cosecant will look like. So cosecant will be the one in yellow. Okay? All right, I hope that kind of makes sense, but all you're doing when you're graphing cosecant and secant is just graphing sine and cosine first, and then making your parabolas off of them and your vertical asymptotes, okay? The last thing on this section is damped trig functions. It sounds like a naughty word, but it's not. Damped trig functions. And I don't talk about these a whole lot. You might have like one of them in your homework assignment. But these damped trig functions is where you have a function in front of your trig function, okay? If I just were to have like a number here, that would just change the amplitude, okay? And really, the x here, this is in fact changing the amplitude because he's multiplying by sine. That's the number out in front, but that x is not staying the same x like a number would. If that was like the number 2 and this was just 2 sine of x, my amplitude would stay 2 the whole way through. But it's changing to be x, so what's happening here is we graph just this x, like y equals x, okay? Y equals x is a linear function, and this is the graph of y equals x. Okay. What are you doing, Ben? Oh. That's the function y equals x, okay? But since sine is like symmetric, we have to look at y equals negative x also because the sine function is going to bounce around there, okay? Now, normally sine is doing like one of these and then whatever, but the amplitude will tell me how high and how low I go. So if I'm bound around those two lines, that's just going to tell me that my sine is going to continue to increase however high the x is. Going up here, I didn't go high enough, but anyway, so my damped trig function is going to look kind of weird just because he's going to be like increasing. It's like the sound wave is increasing. We're like turning up the volume halfway through the song or whatever, you know, it's starting to increase in volume, and that type of thing. So that's just kind of how a damped trig function works. It's when you have a value in front or you're multiplying. It says the product of two functions. So we have x and we have sine of x. Those are my two things that I'm multiplying together. But the x is going to change the amplitude so that he's going to be kind of increasing and bounded around these y equals x functions. Okay, I don't do a whole lot with damped functions, but I think you do have one on your homework assignment that looks like that. So try to use the rest of the time to figure some of those out. We'll go over questions tomorrow and then maybe hopefully start on 9-7. Okay.